Welcome to Sustainability in the Air, the world's first podcast dedicated to sustainable aviation. This show is brought to you by Simpliflying, which has been helping build trust in travel for over a decade. Through in-depth conversation with aviation leaders, sustainability in the air breaks through the current clutter and provides a clear roadmap for the future. It's about time we embarked on creating a net zero future for the industry, together. This season of the podcast is brought to you by Carbon Click, leaders in managing carbon offsetting programs for top global airlines. Without further ado, here is your host, Shashank Nigam, CEO of Simpliflying.
Graham, welcome to the show. It's a pleasure to have you on the show. You, of course, lead sustainability at Pratt Whitney. Would you like to give us a bit of background about your role specifically at Pratt and what sustainability means for Pratt?
Well, thank you, first of all, for having me here today. It's a pleasure to be on the show. And as you've indicated, I was named the company's first ever Chief Sustainability Officer in November of 2021. And my role is to focus our sustainable propulsion technology roadmap and overall strategy, securing funding from a variety of sources, government, industry, partners, and communicating our Pratt Whitney's sustainability capabilities and achievements to key constituencies. Prior to this, I have been my whole career leading development of a variety of different types of gas turbine engines, and I led the development of the geared turbofan engine as both a chief engineer, so a technical lead, as well as a business leader for over 13 years. And so, the GTF engine is a primary part of Pratt Whitney's overall sustainability efforts, and so I've been a sustainability developer for a long time.
Fantastic. Now, you mentioned you're the first Chief Sustainability Officer at Pratt Whitney. What does that role entail? Is it just about making more fuel efficient engines like the GTF, or does it involve something beyond that too?
Well, it's new technologies that we can then bring to bear on our entire portfolio, not just the geared turbofan engines, but all of them. And we're exploring a wide variety of technologies for that purpose, and they range over a time scale that is anywhere from currently off the shelf technologies that we can deploy all the way through to new technologies that require quite a bit of development. And my vision overall is that Pratt Whitney continues as a leader in sustainable propulsion, and that we continue to bring these breakthrough technologies that enable us to support our customers to decouple the enormous benefits of aviation as a key enabler for globalization and all the associated societal and economic impacts that provides from our environmental impact. And that's what we're trying to accomplish.
Right. You mentioned development of propulsion technologies in a sustainable manner. What does that actually mean? You, of course, led the development of the GTF. Please feel free to geek out over this question.
Okay. So, we've been focused as a company on improving engine efficiency and reducing emissions for decades. It's kind of our core DNA. I can cite many examples from our 95-year history, but the recent example is, as you brought forward, the geared turbofan engine that we brought into service in 2016, and because of its architecture, it's a unique geared turbofan architecture where we implemented a fantastic piece of technology, the fan drive gear system that's located between the fan and the turbo machinery. High power density, very lightweight, unique, and robust, with over 13 million hours of time on it. And this device has enabled the fan and the turbo machinery to operate at peak efficiency, and has delivered, depending upon your benchmark, a 16 to 20% improvement in both fuel efficiency and carbon dioxide emissions over prior generations of engines. And that's enabled our customers that have procured those engines to save quite a bit in terms of 700 million gallons of fuel, 7 million metric tons of CO2 emissions to date, and growing. I mean, as we get more out there and they fly more. I'd say that from my career perspective of developing engines for a very long time, 30 plus years, that the geared turbofan engine is the most sustainable engine available today for our customers, and and we're continuing to make it better, as well as our other products, through deployment of new, what we call smarter technologies, these sustainable technologies, as well as through burning cleaner fuels such as sustainable aviation fuel and even hydrogen, as well as leading what we call the greening or greener operations, how we're transforming our operations into having lower and lower environmental impact over time. We chose the geared architecture after very careful evaluation and testing of multiple configurations over decades, including open rotors. And we feel that, once you factor in all the installation and safety and noise issues in the installation of the propulsion system onto an aircraft, that the geared turbofan architecture provides the best solution and the longest runway for growth. And it gives us the foundation we need for all of these next gen technologies going forward, because the architecture just lets us run every piece of the engine at optimal speeds for aerodynamic efficiency, which then translates into overall engine efficiency. Hope I'm not being too geeky.
No, that's the least we can expect from someone who has actually worked on engines, right? My question is, aviation is aiming to get to net zero. Yes, the improvements in fuel efficiency are great and it's commendable, and I know it takes a lot of engineering effort to bring down fuel consumption. But net zero means zero carbon emissions, not fewer carbon emissions, and actually all emissions, not just CO2 emissions. What is the role of engines when it comes to getting to net zero, and how is Pratt getting there?
Obviously, engine efficiency is critical for the relative near term as well as for the long term. And we look at it, by the middle of the next decade, there's going to be 45,000 single aisle and twin aisle aircraft flying, which all have lives of 20 to 25 years, and thus getting the most efficient engines onto those aircraft that are delivered in this time frame is the imperative. And as such, we're continually driving towards greater efficiency in our engines by investing in the technologies like the geared turbofan, but also getting into the hybrid electric space and introducing new advanced materials such as ceramic matrix composites that enable us to just drive additional thermal efficiency. And we're continuing to try to better upon our historic, I will call it, efficiency improvement timeline, which has delivered about 1 to 1.5% efficiency per year. And we're trying to not only match, but even go better than that. And, some examples. So last year, we announced that there are 2 new engines that are retrofits or upgrades to existing platforms that we have, and they're delivering incremental efficiency improvements. So, one is the geared turbofan Advantage gives another 1% fuel efficiency, and then the PW127XT, which gives a 3% improvement in fuel efficiency, both of which are reducing carbon dioxides with the fuel efficiency improvements, and also providing additional benefits such as incremental thrust in the case of the geared turbofan Advantage, as well as longer time on wing and lower maintenance costs in the case of the PW127XT. So, we're really confident in the positioning of our technology portfolio, especially with all of the work we've done on the geared turbofan architecture and the advancements what we're planning as the foundation for our continual improvement and for the industry's continual improvement into the future. And, I can't talk about engine technology without mentioning sustainable aviation fuels. And so that is the largest and most critical pathway of the industry's overall net zero roadmap. And definitely what we need to do is make sure that the engines that we continue to develop, as well as those that we have already developed, are able to operate with sustainable aviation fuels. And currently, we've worked on this since a long time, in 2006. And so right now, we have the capability for all engines to run with a 50% blend, but we're also working to ensure that they're compatible with the future 100% sustainable aviation fuels once they're released. And, as a leading developer of aircraft propulsion systems with experience across, civil, commercial, military applications, regional turboprops, APUs, we fully recognize that our technologies and our products have a very significant role in making the net zero goal a reality, both through our drive to continually improve engine efficiency and also through our work to enable the use of non-fossil based alternative fuels such as sustainable aviation fuel as well as hydrogen. So we're focused on delivering safe, dependable, that's our namesake, efficient engines that will give the airline operators the best fuel efficiency available to ensure that aviation can grow and spread our economic and social benefits as sustainably as possible, and also achieve our net zero objectives in the same time frame.
Now, that's a very, very good overview. You mentioned SAF. So let's deep dive into that. The UK Transport Minister recently challenged the industry to operate the first flight operated by 100% SAF by the end of 2023. What will it take for engines to get there? Because my understanding is currently engines can only take 30% SAF, not 100% SAF.
So um, there's a lot of elements to sustainable aviation fuels or SAFs. And so, we'll go through a number of those pieces. First, we talk about 100% SAF. Part of our challenge is that we have to define what is 100% sustainable aviation fuel, because we don't have a standard definition yet. And that's what the main industry regulator for fuel specifications is working on, the American Society for Testing of Materials International, ASTM International. Customers clearly want to get to 100% SAF. That's obviously what we're trying to do. And ASTM specs are designed to enable drop-in capability or compatibility with, which means that the sustainable aviation fuels are blended with up to 50% of conventional Jet A and A1 kerosene, so that the fuel's chemical properties are identical and they can be used across all existing aircraft infrastructure and infrastructure. Blending with kerosene is needed because SAFs in their neat form mostly lack a key ingredient, which is found in fossil-based fuel, which is called aromatic hydrocarbons. And these are needed for the nitrile rubber seals in older engines and fuel systems to swell and prevent leaks. And leaks are obviously bad because they can cause fires. So nitrile rubber is no longer used, at least in Pratt Whitney's current and production engines. So the absence of aromatics is not an issue for our current production as well as future engines. But given the continued operation of thousands of older legacy aircraft and fuel systems over the coming decades, it's important to have a drop-in standard to ensure compatibility and minimize operational complexity across that whole global fleet. And that's why the industry and ASTM are in the near term focused on specifying a 100% drop-in SAF. For example, by blending two or more different SAFs together to achieve the minimum level of aromatics so the fuel can be used on all previously certified aircraft. And ASTM intends to have that 100% drop-in SAF ready for ballot and approval next year, as early as next year, so could make it available. So we have a program underway at Pratt so that all of our engines are able to operate on 100% non-drop-in SAFs. And we've recently tested our GTF Advantage engine with these non-aromatic 100% SAFs, which when we did the testing, no change to thrust, operability, no issues with any of the hardware in the engine, and all results as expected. So we can confidently state that all of our gear turbofan engines are compatible with 100% non-drop-in SAF, and we'll be ready once the new standard is established.
So this is more for the regulators to authorize these engines rather than you, the manufacturer, to work on the technical specifications.
Well, we all play a part. We play a part in terms of defining the compatibility of the different fuels as they come forward. The regulators on their side are ensuring that that is safe and also capable of being used for all operators in a safe and consistent fashion. And so when we look at it, the key is that when you have 100% non-drop-in fuel, it's no longer capable of being used on aircraft that are not certified for its usage. And so those older aircraft wouldn't be able to fly a non-drop-in capable sustainable aviation fuel. So over time, we will see those aircraft retiring, and then eventually they'll be replaced by the newer generation of engines and aircraft that are capable of running what we call the non-drop-in SAFs, and so they will enable wider usage. But it's going to take time to phase that into service as those aircraft phase out.
Right. So now I have worked with Pratt and engines for a long time, and I know it's a B2B to B2C business. So translating this down to the customer, there are certain types of new engines which can take 100% SAF. Which aircraft currently fly these engines? Is it the A320neo? If I'm a customer, if I'm a traveler on an airline, which aircraft am I likely to board, which may be flying on 100% SAF in the future? Is it the A220? Is it the A320 Neo? Is it the Max? Which ones is it?
Well, what I can tell you is that at least from an engine perspective, the A320 Neo, which was powered by our PW1100G, is going to be compatible with what we envisioned the future 100% non-drop-in SAF with low aromatics. So that aircraft and engine combination will work. We would also state the A220, also powered by the PW1500G, from an engine perspective would be good to go. And then the PW1900G powering the E190 and the E195 would also be an engine combination. And then I can't speak with confidence to my competitors' products, but from seeing what they're doing, I would anticipate that they also have similar capabilities for their newer in production products, such as the LEAP products that are powering the Max, as well as the A320 Neos, as competitors to us.
And are there airlines you're working with, or is it primarily OEMs and manufacturers that Pratt would work with in bringing 100% SAF to the public?
Well, it's a partnership for everyone, I'll have to state. On our side, we work with fuel manufacturers in particular, as we have the expertise to understand the, shall we say, compatibilities. And so as such, we're able to bring that technical expertise to bear as we support fuel companies who are at the same time trying to expand the uptake of SAF throughout the entire industry by working on different feedstocks and also different processes to do two things, is to expand the availability of sustainable aviation fuels, which we haven't even mentioned is in very low supply, as well as to reduce the cost, which is because of low supply, and also the cost of feedstocks and the cost of processing is high. Let's just say 3 to 5 times higher, depending upon what markets you're in. And so, what we're doing on our side is the technical folks is we're working within the industry to expand the number of available sustainable aviation fuels that are capable of being produced, and we're more importantly working upstream with fuel providers such as Airbnb, which we signed an MOU with, so that as they're working on their future sustainable aviation fuels, we can provide them with the technical expertise to state that, this fuel has or has not the capability of going forward and being used in volume production as they develop those. And as well, we'll be conducting testing, validation, emissions, and other things along the way as part of those partnerships. So from our side, it's ensuring compatibility and ensuring the expansion of multiple SAFs for their capacity and also reducing their cost over time.
Yeah, no, you're absolutely right. SAF is one of the key technologies that will get us to net zero and get us on that path. But it comes with its own challenges. In my interview with Gevo's CEO recently, I learned that yes, indeed, there's short supply, and there is indeed a green premium, which is closing as SAF scales, but it's more expensive right now. Hydrogen is something else that Pratt and Whitney has been working on as an alternate, because it does offer an alternate to SAF, especially on shorter sectors. What's the hydrogen story for Pratt and Whitney?
For us, we see hydrogen, as an important and key, shall we say, enabler for this transition of our, I'll call it aviation ecology, fuel ecology in particular. And we see that from the perspective that, first of all, hydrogen has to be green. There's all kinds of, I think, there's all kinds of colors of hydrogen. There's green hydrogen, there's pink hydrogen, there's blue hydrogen, and there's gray hydrogen. And so we're focused on supporting green hydrogen, and for two reasons. It's both as a primary feedstock for the development of sustainable aviation fuels. It's you take a hydrocarbon mass and you add hydrogen to it, and you start to generate hydrocarbon chains to make fuels out of. And so there's a key role for green hydrogen in that perspective. But also, there's the opportunity for us to use hydrogen as a non-carbon atom containing green fuel. And so if you have green, hydrogen, then you have basically questions about what approach you take. And there's multiple opportunities for aircraft propulsion and electrification, whether it's based on hydrogen fuel cell type of technologies or whether it's based on hybrid electric technologies. And so there are many studies that are out there and development programs as well that are aimed at hydrogen aircraft propulsion systems, and most of these are based on fuel cells, which use gaseous hydrogen to produce electricity on board. But in our case, we've explored through Collins and Raytheon Technologies research centers. We've been working and have been leaders in fuel cell technology for more than 60 years. And we have multiple applications ranging from the Apollo space program, Pure Motion and Pure Cell product lines that we launched after that, to the Spanish Navy's S-80 submarine. So a lot of research in both polymer electric membrane and solid oxide fuel cell technologies. But what we're seeing is that despite all of that tremendous technology, fuel cell technology capability has limits, and the limits are to relatively small aircraft with limited payload and range. And that's because the specific power and specific energy of the fuel cells are kind of low compared to those of jet fuel, and require substantial advances to achieve flight weight needs of systems for these larger aircraft. And so we also see fuel cell varies inversely with current density through the membrane. So to achieve higher efficiency, you have to have, per unit area, the current density per unit area has to be kept low, which means that you have bigger and bigger membranes, which increases area, volume, and mass. So we've taken a hard look at it, obviously, and we have quite a bit of experience. And we are now focusing our efforts on more novel approaches, including high efficiency hydrogen fuel propulsion systems for commercial aviation. We call this HiSight, and we're developing it with support from the Department of Energy's ARPA-E. And for hydrogen combustion technologies like this HiSight project, we're using liquid hydrogen fuel minus 263 centigrade, and we're using the significant opportunities that fuel provides for driving efficiency and optimizing our future hybrid electric propulsion systems. And looking at that, what we're doing is we're taking hydrogen cryogenically, and we're expanding it and expanding the cryogenic liquid, converting it to a gas, because you have to burn gas, you can't burn liquid. We extract a tremendous amount of energy, which can be used for electrical power generation. We also are capturing out of the exhaust stream water vapor, and there's like 2.5 times more water vapor present in hydrogen than there is in kerosene, and we're capturing that in a condenser, and then we're converting it by converting the heat from the exhaust gas stream into steam. And then we're taking that steam and we're doing a couple of things with it. One thing is that we're inserting it in upstream of the combustor, and we're doing that to enable the combustor to mix with hydrogen, because hydrogen has a very high flame speed, and it's hard to control. So by mixing it with steam, you can control it more. And then the other thing it does is it cools things down. So you're able to reduce NOx emissions, which is another pollutant of concern for aerospace, by about 70, 80%. And so that's what we do with the combustion side. But we also take that steam and we're using it upstream to intercool the compressor in the compressor stages, and that drives additional efficiency. And so the combination of that plus using some of this steam to cool our turbine down creates a cycle that is delivering 35% higher energy efficiency than what we can deliver with today's turbofan engines. And so we're very excited about it overall, because I haven't mentioned the key challenge with hydrogen is that the volume is larger. The specific volume is 4 times that of kerosene for an equivalent trip from A to B. And so one of the key things we need to do for these future generation of hydrogen propulsion aircraft is reduce the amount of fuel that has to be carried by having these higher efficiency systems. And that's how we're focusing on it.
So I find it quite fascinating that you're cooling hydrogen to such a degree that it's liquid, and then you use steam to cool it further. So steam is like the hotter thing, and you're using it to cool it. One of the things, though, with hydrogen that is, unlike SAF, it's not a drop-in. Hydrogen requires specific storage, specific precautions when it's being transported. Do you see that as a challenge with hydrogen compared to SAF?
Yeah, I would definitely state that is the challenge. I think that you have to stand up a new ecology, as I've stated previously. SAF, it pretty much already exists. You can use existing infrastructure to deliver it to the aircraft, to fly in the aircraft. we talked about nitrile rubber seals. You throw that aside, it's a pretty easy transition. You look at hydrogen, whether it's gaseous or cryogenic, you have a lot more problems that you have to deal with because of the nature of that fuel in terms of generating it. And as we mentioned, it needs to be green, not pink, gray, whatever. And also having it so that it can be used, because there is a certain degree of, when you, especially in the cryogenic form, the liquid form, there's a certain amount of losses that you experience. And let's just say you're losing 1-2% of your fuel every day. So you need to make sure that wherever you're producing that hydrogen is close to where you're using the hydrogen to avoid those losses. And it also puts a lot of challenges on the airlines relative to how they are going to fuel their aircraft up. So in the end, I would view the infrastructure, the development of the underlying infrastructure for hydrogen to be the schedule pacer for the implementation of hydrogen on a realistic basis on global scale, as compared to the aircraft and engine technologies, which we've been doing hydrogen fueled aircraft since the 50s. Going back to a project that we ran with Lockheed Martin, Skunk Works. And there we ran squarely into the challenges of the high volume, and that then driving and rippling through the aircraft structures to create an overall aircraft that was too heavy and too large to fly, which is now why we're taking this novel approach with a system that actually uses cryogenic hydrogen in a variety of different ways to create an overall thermodynamic cycle that is highly efficient and thus enables less fuel to be carried on the aircraft to go from point A to point B. That's our overall approach.
Right. It's great to see how you're thinking about this in a holistic manner and end to end. One of the collaborations I recently came across was that you're working with de Havilland in Canada to retrofit Dash 8s. What's that program about, and how's that working out?
It's interesting. This is like I mentioned, the geared turbofan engine was one of our really proud moments from a technology perspective. Well, we're just as excited with this hybrid electric technology that we're developing in partnership with ourselves, de Havilland. Collins Aerospace is coming to the party, bringing all of their electric expertise to the party. And then, of course, we've got strong support from the Canadian government, including both Quebec and the Canadian Strategic Investment Fund. And so there, what we're working on is we're replacing the PW121 engine. That's about I'll just say in rough numbers, a 2 megawatt gas turbine engine with a combination of a 1 megawatt thermal engine and a 1 megawatt electric motor and drive system that's being produced and provided by Collins Aviation. And so there, it's a 50-50 parallel arrangement that we're looking at. And what we will do is we will run both of those, both the thermal and the electrical engine, in parallel at high power requirement phases, such as takeoff and in climb. But once we get up to altitude and we're cruising, the thermal engine is very, very efficient. So we'll take off the electric power, and then that enables the thermal engine through a genset to charge the batteries back up. And then we'll land the aircraft and start all over again. But despite that, there is quite a bit of challenges. We're having to go to a very high voltage system for the electrical system between the aircraft and the propulsion system, 1,000 volts. Currently today, we're limited to say 300 volts. And that's required for us to size down all of the power electronics and also reduce the amount of heat that's being generated by the electrical system, which is very hard to get rid of when we're up in the altitude. So, a lot of key technologies we're working, how we integrate the hybrid electric system together to bring out the best overall efficiency. And right now, what we're looking at is something that we're seeing delivers a 30% improvement relative in terms of efficiency relative to its baseline. So a very strong shot. And we see these technologies as being critical for a wide range of future products, be they regional turboprops like we're doing, with the Dash 8 into Havilland, or scaling them down to general aviation size or even APUs, as well as scaling it up. And we're actively, putting the same electrical system that we're using on this de Havilland aircraft and marrying it up with a larger 18 megawatt geared turbofan. So you have, instead of a 50-50 hybrid parallel array, you're having more of of a 5%, 95% kind of an arrangement. But nonetheless, we see strong benefits from all of those cycles when we net out all of the impact of the batteries, the power electronics, and the efficiencies that they're provided in terms of driving overall thermal efficiency. And then, as I've indicated previously, all of these thermal engines will be fully compatible with the latest 100% SAF fuels when they're released. And so we'll add additional improvements to the overall carbon reduction from a sustainability perspective.
Right. Now that's quite fascinating. So we've discussed how SAF is being incorporated, and 100% SAF should be a reality within the next year or so. We've talked about hydrogen and liquid hydrogen being incorporated in the engine systems. We've talked about thermal electric experiments you're doing with Dash 8s as well. Going forward, which of these technologies or something else do you feel offers the biggest opportunity for airlines to get to net zero?
That is the fun part of what we are in, like a very, very disruptive time in our industry, and that's why it's really exciting to be an engineer, because it's really hard to put your finger on what's going to be the best. You have to work a portfolio so that as the future develops, and we've already talked about hydrogen infrastructure, will that happen? Is the timeline right? So we're working hydrogen, we're working the hybrid electric, and we're working engine efficiencies. And so in terms of probability, it's almost like reverse order. So thermal efficiency in engines, that's something that we know we will continue to do. We've been doing it for 95 plus years, so we're going to continue to do that. Hybrid electric, we definitely see that as being something that we will continue to develop. And as battery technology continues to mature, we think it'll get better. And then as the hydrogen economy starts to unfold over time, that will be when those technologies will come to bear and be available for the wider public usage. And so, if you're not playing in all these three elements, then you're potentially missing out on, the ability to not only deliver more sustainable products, but also to be competitive in this, shall we say, disruptive environment that we're currently in.
Right. Now, a lot of airline executives listen to this podcast. If I was to ask you, for an airline executive who's just starting out on this sustainability journey, where should they get started?
From my perspective, I would say that you need to look at your fleet composition as your first step, because typically a lot of airlines are still flying older generation aircraft that are less fuel efficient. And so looking at your fleet, you can make decisions on the basis of economics plus sustainability on what your fleet composition should be. And certainly we at Pratt Whitney would love to have all of our airline customers buy more geared turbofan engines and advantages as they become out into the environment. And so fleet composition and fleet renewal is certainly one major element for a sustainability minded airline executive. And then the next thing I would mention is, of course, sustainable aviation fuels. Finding how you get sustainable aviation fuels, how you get the pricing right, getting the contracts with producers, continuing to establish and engage in support for policies on a global basis that will enable the capacity to build and the price to become more in line by creating a level playing field with fossil fuels. So, within your own, governments, beginning to work and ensure that they understand the criticality and the importance of sustainable aviation fuels, as a key next step. And then, of course, the third thing is, once you've done those two things, there is an area of offsetting and out of sector elements that, a sustainability minded airline executives should be aware of and pursuing. Obviously, it's not as popular as the prior two ones, which are definitely methods to reduce. But we're looking at this and we're seeing that the necessity is there, especially in the near term, to help offset and decarbonize our industry. And then last is keep looking at all the great technologies that the airline or the OEMs are producing, both aircraft and engine manufacturers, and seek to find ways to introduce those technologies over time as they become available and the infrastructure and other issues become clear.
Right. No, fantastic. That is really good advice to anyone starting out, because it can appear like a wild west out there with so much going on, so much change happening. What I'm excited to hear is that this is an exciting time for you as an engineer, because it seems like there are challenges worth solving and you're making significant progress. And I'm really glad to hear that.
We are as well. I mean, in the end, we need this whole industry as a whole to become educated and aware of our challenge as an industry to achieve net zero. And I think that the types of podcasts that you're doing are going to help to bring and enable that education and awareness to grow and advance so that we can begin to, as a collective industry, take on this huge challenge that we're faced with. And then, the other thing I'll mention is that, of course, in order to enable us all to make this happen, we need the best and the brightest people, employees, to help us to keep innovating, long into the future. And obviously, sustainability is a key element of the recruiting programs that we have, and I would state that other parties within the industry have, to focus on attracting that wonderful, top diverse talent that's out there, and of course then sustain that through robust mentoring programs, to retain that talent and make sure it stays in the industry and continues to do these great things that we need for the decades to come.
Absolutely, Graham. It's been a pleasure speaking, and I'm very glad we could deep dive into some of these concepts, and I'm excited about some of the technological efficiencies and the road to net zero that Pratt & Whitney is leading. Congratulations, and thank you very much.
Well, thank you. And it has been a pleasure speaking with you today.
Thank you for listening to this episode of Sustainability in the Air, the world's first podcast dedicated to sustainable aviation. We hope you liked it and will share it with your network. Please also leave us a review. Awareness is the key to a green future. Your support will help our insights on sustainable aviation reach a wider audience. In addition, for every single listen of this podcast, we will plant a tree, and for every single review, we will plant 50 trees. You can also write to us at podcast@simpliflying.com. And for more content on sustainable aviation, please visit our website, simpliflying.com, and join the movement.